Good morning, all. This is Jane Jandatimba, and welcome. Thank you all for attending our County of San Diego 2020 update to the San Diego BMP Design Manual. So we can't see you all, but we're very, very glad that you've joined us, and we can't wait till the next time we can get together in person. We've got an exciting 3 hours of presentations, and next, so we're going to go over the agenda, and I'm Jane Jandatimba, a principal at Rick Engineering Company, and will be moderating today's presentation. So all of your microphones are muted at this time. What we're going to ask is that you provide any questions that you have for our speakers today in the Q&A button at the bottom of your Zoom. The chat is also available, but that's going to be chat for all of you internally. Please don't provide any questions that you have of the presenters in the chat button. Please put all your questions in the Q&A button. We also have breaks scheduled for today. We've got 5-minute breaks, so we all can go do what we need to for 5 minutes. And this presentation is being recorded. So we just wanted to make sure that you all were aware of that. And then at the end of the presentation, we're hoping you'll stick around to answer a quick poll. Next. All right, so today I'd like to present our speakers to you all, and I've got just short bios for our speakers. We're starting off with Renee Vidales, is a program coordinator for the County of San Diego in the Watershed Protection Program. He is a registered professional engineer and has over 2 decades of experience in all phases of land development, including both private and public sectors. Next, we have Julie Hughes. She is a land use and environmental planner 2 for the County of San Diego in the Watershed Protection Program. She has been with the Watershed Protection Program for 2 years. She also has worked for the private sector for several years as a stormwater consultant for the construction general permit compliance. Next, we have Jeremy Fantaroni. He is an environmental planner 3 for the County of San Diego in the Watershed Protection Program. He has a master's degree in environmental engineering and has over 15 years of experience in stormwater field in both the private and public sectors. And lastly, we have Laura Henry, is an associate water resources project engineer at Rick Engineering Company's Water Resources Division. She is a registered professional engineer. She has been in the Water Resources Division for over 20 years and has worked on a variety of projects, including stormwater management and drainage design, contributing to local design manuals and standards and plan review. Next. And today we've got 3 slides that identify our agenda. So first of all, we're going to have Renee up providing us a summary of the changes and miscellaneous edits. Then Jeremy will be discussing the new Appendix C and also tables 1 and 2 of the standard and PDP swamp forms. And in this first session, Renee will conclude with updates to chapters 2 and 4. We'll have a Q&A session for those speakers. So once again, please put any questions you might have for these topics in the Q&A chat. And then we'll have a 5-minute break next. Then we will jump into, Laura will discuss the new Appendix I, and it will be followed up with updates to chapters 5 and 6. And appendices B and G. And then we will have a Q&A session then. Then we'll have a quick break, and then we'll go into, Renee will be up describing the significant site design BMP tool. Laura will present an example project, and we'll have a Q&A session for those presenters. And we'll conclude this morning with verification and maintenance requirements for significant site design BMPs. Julie will be presenting on that, and Renee will conclude with recommended best practices. We'll have final closing and final Q&A. And then, as I mentioned before, we'll have a poll survey. So now I would like to turn the presentation over to Renee to talk about the summary of changes and miscellaneous edits. Renee?
Thanks so much, Jane, and welcome everybody. Good morning. As Jane mentioned before, if it wasn't for the pandemic, we would have been face to face at the county hearing room having this workshop. But unfortunately, we're doing the best we can and doing it virtually. So here we go. This is going to be a fun ride. I'm going to start with a summary of changes and miscellaneous edits, and just trying to cover, the more editorial edits and an overview of, what we're doing. Next. So the best way to be able to access any information on the county website is to just type SanDiegoCounty.gov/stormwater. So that will take you to the landing page of the Watershed Protection Program. And in there, you'll find 8 droplets, similar like the one you see at the bottom there. So the one that you want to go to is development resources. For everything that we're discussing here, for the most part, will be under development resources. So again, SanDiegoCounty.gov/stormwater, and then go to the droplet that's titled development resources. Next. This will give you on the left, more or less what the summary of changes handout looks like, which is also posted on the county website, and this time will be under manuals. There's one of the categories that's under development resources, and then BMP Design Manual. This doesn't necessarily open up a new page when you go into the categories. So the updates are structured right now from the last update that we made in January 2019 all the way to September 2020, which is the current edition. Next. A little bit of context here for history. Originally from the 2013 municipal stormwater permit, all the co-permittees, which were all the incorporated cities in Region 9, which is 18 cities, plus the San Diego Regional Airport Authority and the Port of San Diego, including the County of San Diego for the unincorporated areas. All of us gathered together and put together the model BMP Design Manual, which is the one on the far right. So also every jurisdiction put together its own BMP Design Manual to incorporate local specifics. Sometime in 2018, in May 2018, the model BMP Design Manual was updated, and therefore most of the jurisdictions, not all of them, decided to update their own BMP Design Manual too, which the county did and released it in in January 2019. So we went from a February 2016 all the way to January 2019 version, and we published a summary of changes. And then we go to the left, which is where we are right now. We updated the County BMP Design Manual effective September 2020. And this incorporates the summary of changes on the far left is what gives you, what were the edits that were made from the January 2019 version all the way to the September 2020 version. Just for additional background, the model BMP Design Manual was updated was published in May of 2020, which is this year, just to incorporate some editorial edits. Even though I'm not showing the screen on the left for the model BMP Design Manual, there was a minor update. Next. All right, so we have, these are the minor edits of the more editorial side of things. So I grouped them up into 9 different categories just to make it easier to go through them. The first one is the beginning of manual and the glossary. The second one is Chapter 1 and Appendix L. Third one is swimming pools and water features, so as PDP threshold. Fourth one will be conjunctive use handout. Then INF3, which is a BMP added to the engineer impervious surfaces table. Then we moved source control fact sheets from Appendix E, added filter course layer info, added impermeable liner info, and then made a connection of the Green Street standard drawings and specs into Appendix K. Next. So let's start at the beginning of the manual. So as you know, we have a new cover with a new photo, and we also changed the effective date, which is September 15th, 2020, which is this year. Also, we obviously, like I've shown before, and we updated the summary of changes. We also updated the internal memo, which gives the green light to go ahead and publish the County BMP Design Manual. We also added a paragraph to the summary, which includes the chronology, which lists that this is the latest update to the BMP Design Manual. And then lastly, which is at the end of the manual, we updated the glossary to edit some terminology. Next. All right, so we're in Chapter 1 in Appendix L. So it's just the only change is one change globally, and it's replace the term of grandfathering with the term exception. And, just to be more sensitive to today's times, if you Google grandfathering, you'll see there's some connotations in there. So we don't want to be part of that. So, in our written guidance, so we went ahead and updated that. So it's just a minor update. It's just editorial, but just wanted everybody to know that that was done. Next. In Chapter 1, in Section 141, we removed language which is shown struck through at the bottom, which is swimming pools and decorative ponds. So the reason for that is this is one of the exclusions that is listed in the manual for areas that can be excluded from impervious area calculations towards determining if the project is a priority development project or a PDP. So the one that remains is anything that's listed in Table 1-2 that tells you that all of the areas that can be considered exempt from the stormwater requirements, such as routine maintenance, resurfacing, etc. So you don't count those as impervious surface. So I'm just going to give you a little bit of an example here. Let's just say that you have a brand new development project with it's a residential single-family home, which if you count the roof, if you count the all the impervious surfaces, sidewalk, driveway, etc., they'll give you, if you have 9,800 square feet of impervious surface as a new development, that doesn't put you into the prior development project. But if you add a 500 square foot swimming pool, you have to count that as impervious surface towards your PDP threshold. Again, this doesn't affect the calculations for treatment. You still count the pools as you've always count them, but for the differences for impervious surface towards PDP applicability, you have to count them as swimming pools and decorative ponds as impervious. Next. A lot of questions and a lot of discussions. There's information that wasn't included in the manual in the past. And part of that was that we didn't have information about what do you do when you have flood control and you're combining it with pollutant control and hazard modification management. So what you do is you don't have enough information. Obviously, you go to the hydraulic design manual and you don't have enough information. So what we decided to do is put together a conjunctive use handout. And we decided not to make it part of the manual. It's posted on the Development Resources website under modeling software, and it describes all of the scenarios that you can have when you have flood control and you're combining it with hazard modification management and or pollutant control. It's about an 8-page handout. Next. So similar to the previous section in Chapter 3, now we also have Chapter 4 in Section 415, and it's pretty much the same situation, that we refer to the County Hydraulic Design Manual and make sure that we have to comply. If you're doing the same thing, where you're complying with flood control, but at the same time, you want to use the same facility for pollutant control and hazard modification or flow control. So there is a conjunctive use handout, again, separate from the manual, and it's posted there in the Development Resources website under calculators and modeling software. Next. This is the table of the table B11, which is the runoff factors. We decided that we do have permeable pavement listed under engineered pervious surfaces, but it's listed as a site design BMP, permeable pavement, but we didn't have the structure BMP permeable pavement listed in there, so we just decided to add it there. It doesn't change anything other than just clarify that if you have that type of permeable pavement, that is also under that particular category of engineered pervious surfaces. Next. We removed all the source control fact sheets from Appendix E, because that's the big change, is that now we have all the source control fact sheets in the new Appendix C. So we removed the source control fact sheets from Appendix E. We updated the table. Now, I'm going to talk about this table later in the presentation as to how it's currently labeled, but it's basically removing those type of source control BMPs from Appendix E. Next. Appendix E, we have three types of BMPs. We have BF1, which is biofiltration, PR1, which is biofiltration with partial retention, and then we have INF2, which is bioretention. So we have all those three types of BMPs, and we didn't have any information, or at least not much information, on the filter course. So we decided to add this language, which just clarifies and gives you context. Minimum 6 inches of thick provided in two separate 3-inch layers. Top layer shall be made of ASTM C33 choker sand, and the bottom layer shall be of ASTM number 8 aggregate. So just additional language to clarify. Next. In Appendix E, this is the biofiltration BMP. We realized that we had the exact same figure for the 3 BMPs that I mentioned before, and sometimes when we have the same type of figure, exactly the same, ends up being confusing. So the biofiltration is supposed to have an impermeable liner, so it's not optional. So we removed the word optional from that figure. That's the only change we made. Next. Appendix E will also have the biofiltration BMP. There were some questions that were asked about the thickness of the impermeable liner. So we already had that information, we just didn't make the link. So it shall be 30 mil for County Design Standard Drawing GS 3.00 and County Green Street Supplement to Caltrans Specs 20-11.08B. So the information was already there since we published our Green Street Standard Drawings and Specs, or we made the update about a year ago. 30 mil is about the thickness of a credit card, just for reference. So again, we didn't have this, and now we have additional information on the thickness of the impermeable liner. Next. We wanted to make a link to the county, the update to the county design standard drawings for Green Streets, and also the specs, the specification for Caltrans and Green Book that refer to the Green Streets. So we just updated the information so you can find it easily. It's under the Development Resources website under Green Infrastructure Resources. And again, these were updated about a year ago, so that's the only connection we're making this time around. Next. All right, so I'm going to pass it on to Jeremy Fanteroni to go over the site design and source control fact sheet, which is the new Appendix E. That's one of the changes that we made comprehensively in the manual this time around.
Okay, thanks, Renee, and good morning, everyone. Yeah, so today I'm going to discuss the new site design and source control fact sheets in the new Appendix C. Next slide, please. So the overall goal of creating these fact sheets was to consolidate the site and source control information into an easily referenced location. So when a customer is completing a PDP or a standard SWQMP form and wants more details about the source or site design BMP, they can find it in the fact sheets. In the past, we were having kind of a hard time pointing people in the right direction when they're asking specific questions regarding, well, what's this site design, or what's this source control, and what does this actually mean to my project? So as you can see, we consolidated the tables on the left. That was the old worksheet. We had some existing fact sheets, so we consolidated them all into these new fact sheets and put them in Appendix C to try to streamline this process. So I'll just go over some definitions just to make sure everyone's on the same page. What a baseline BMP is. A baseline BMP means any BMP that is required where applicable and feasible in all development projects. Baseline BMPs include both site and source control BMPs. Some baseline BMPs can be sized to qualify for DCV reductions on PDP projects. So a baseline BMP is basically applicable to all projects, and it's basically your site and source control BMPs. They're for PDP and standard projects. Site design BMP is a stormwater management and land development strategy that emphasizes conservation of natural features and the use of on-site natural features integrated with engineering small-scale hydrologic controls to closely reflect pre-development hydrologic functions. So site design BMP can be something as simple as dispersing to a permeable area, for example, or it can be a little more engineered with a tree well. And a source control BMP is a land use or site planning practice or structures that aim to prevent runoff pollution by reducing the potential for contamination at the source of pollution. So source control BMPs minimize the contact between the pollutants and the stormwater runoff. And then these fact sheets do not include enhanced site design BMPs, structural BMPs. Those have all been consolidated in Appendix E. So here's the table of contents for the new fact sheets located in Appendix C. I'll just go through the columns. It provides the MS4 category, whether it's a site design or a source control BMP. Also gives the baseline BMP fact sheet name. We have BL1 through BL7. And the baseline BMP fact sheet kind of is the activity or feature that trying to mitigate. And then within the fact sheets, there's BMP IDs. So these are the actual BMPs that you'll show on the plans, the BMP ID that you show on your exhibits and plans that point to what BMP you're using to mitigate the potential pollutant generating feature. If it's in italics, it means we already have a fact sheet, and we just reference it. And those fact sheets are in Appendix E, but we discuss how they can be relevant. They don't have to be designed for DCV reduction in all cases, and you can incorporate them into a standard project. And then if we didn't have a BMP ID, they're located in the fact sheets. So so here's just the format of the fact sheet. The baseline BMP fact sheets are formatted to display all the relevant information. Again, we did not necessarily create any significant amount of new content, really. We just rather consolidate content we already published in various documents. However, we did create some new content based on our experience. So each fact sheet has this quick reference, as you see right here. It gives you the MS4 category and the BMP ID that's within the fact sheet. And then we have the applicable site features header. This section describes typical features like work areas, landscape areas, rooftops, where this fact sheet pertains to on your project. And then we have a SWQMP baseline BMP header, which describes which BMPs are applicable and how you document in the project SWQMP. And then it gives you some more, in some fact sheets, it gives you more details about the BMPs, especially if there's one in Appendix E, and how you can incorporate it into like a standard project and how it's relevant. And so, so the last slide depicts the fact sheet elements. Now here's if there's a BMP ID within the fact sheet. So the first header is description. It provides an overall summary of what the BMP is and where it is commonly applicable. The next one is design considerations. This provides a more detailed discussion about like the placement, location, typical materials used for the BMP. And also sometimes it contains references to other publications that are relevant. Then the plan requirements. This section provides a table that discusses the plan view requirements, detail sheets, and typical construction notes. And then maintenance considerations, what maintenance you're expected to do on these BMPs. So next slide, please. So here's an overall, here's an example of a completed, putting all those elements together. As you see on the left, that's BL4, landscape areas. It has this little reference guide, and then talks about the applicable site features. It has the SWQMP baseline BMP requirements, and it has the it provides the example of the SWQMP table it's associated with. And then on the right, you can see it's SDK, that's the BMP ID, and then we consolidated all the information pertaining to that BMP in this section. So it gives you a description of what the BMP is, then possible design considerations, and then plan requirements. Okay, so now I'm just going to go through each one of and just kind of highlight each one of these, BL1 through BL7, just kind of describe what's in each one. I can't go into too much detail, but I'll try to hit the highlights of each fact sheet. So this is BL1, existing natural site features. It's a site design. And then the BMP IDs within this fact sheet are SDG, conserve natural features, and SDH, buffers. So the basic concepts of this fact sheet are to design projects around any important natural site features of the site where applicable and feasible. You can see this little graphic on the left kind of describes that as the least sensitive habitat to the most sensitive habitat. You want to avoid things like wetlands, sensitive species, and you may want to construct in areas that are devoid of vegetation or previously grading areas. So it kind of gives you an overall sense of what this fact sheet's trying to mitigate. So there's two BMPs, BMP SDG, conserve natural features, provides design considerations such as maintaining existing site drainage and hydrology, avoid and or restore natural areas and prevent construction phase impacts to soils. And SDH buffers describes where buffer zones may be feasible, setbacks, hydraulic disconnection, and other options to conserve natural areas on the site. And then the next one is BL2, baseline fact sheet number 2, outdoor impervious areas. So this is a site design, consider site design, BMPIDs in it are SDB, impervious area dispersion, and SDI permeable surfaces. So typical features where this is applicable are streets and roads, sidewalks, driveways, hardcourt recreation areas. There are generally 3 practices that are covered to meet this requirement. There's number 1, you direct runoff to pervious areas. That would be SDB, impervious area dispersion. Another BMP you can use is construct surfaces from permeable materials. That would be SDI, permeable surfaces. Or you can minimize the size of the impervious surfaces. You can't show that necessarily on a plan, so it's something that I think folks do for the most part now anyway to try to minimize their area they need to treat or so they don't meet PDP thresholds. So I feel like that's being done already. So in regards to permeable surfaces, SDI, the fact sheet discusses typical non-engineering permeable surfaces that you can incorporate into like more of a standard project. You can see them on the left, like decomposed granite, cobbles, crushed aggregate, reinforced geotextile features. You don't really have to have like an engineering drawing, even though I always recommend one, but you can integrate it into that to most projects. However, if it's a more engineered pervious concrete, asphalt, pavers, then we would refer you to the SDD fact sheets, which gives much more detail about those types of surfaces. Okay, and so the next one is BL3, rooftop areas. So this is a site design BMP again, and the BMPs covered in this fact sheet are the SDB, impervious area dispersion, green roofs, and rain barrels. So again, if and there's the SWQMP form checklist. You check if you have a rooftop area, and then there's 3 options there. You want direct runoff to pervious areas. If you want to install green roofs or install rain barrels. And then we already have existing fact sheets in Appendix E for each one of those items. Okay, so this is the BL4, landscaped areas. This is site design again. BMP ID in this one is SDK, sustainable landscaping. So the landscape areas fact sheet, it generally points the customer to resources they can use for design. It describes the San Diego Sustainable Landscapes Guideline, which provides a detailed watershed-friendly approach to landscaping. You can see it on the right-hand side, and we provide a link to it and discuss how it's applicable and meets these requirements. And then we also have, and if your project proposes over 500 square feet of landscaped area, it may need to comply with the county's landscape ordinance. So the one on the left is the county's Watershed Efficient Landscape Design Manual, which guides customers through the design requirements if your project does need to meet the county landscape ordinance requirements. Okay, so the next one is BL5, work and storage areas. This is our first, so all the previous ones were site design, so this is a source control fact sheet. The ones, the BMP IDs covered here are SCA, overhead coverings, SCB, berms and grade breaks, and SCC, wind protection. So some typical areas where these BMPs are applied are trash areas, maintenance and repair, and storage areas. There are 3 BMPs that this fact sheet covers to mitigate these areas. Again, the overhead coverings, SCA, that's to prevent rainfall from contacting potential pollutant areas. The berm and grade breaks, that's to prevent run-on from flowing through a pollutant-generated area. And then wind protection to prevent pollutants from being transported by the wind in those areas. All right, and now BL6, management of stormwater discharges. This is a source control BMP. And the BMP IDs here are sanitary sewer and containment areas. So if there's a potential for pollutant generating sources being proposed, they must be designed to ensure the stormwater runoff is properly managed. This fact sheet provides 3 options where these areas can be routed to. So the first one is sanitary sewers. So if a project uses this option, it must get approval by the sanitary sewer agency. So we created a list of all the sewer agencies in the county of San Diego. You can see on the left, sewer agency name, their address, provides a telephone number, and also provides their organization. And number 2 is containment areas. A containment area are specifically designed storage or activity areas that prevent spills, leaks, and other discharges that would otherwise pollute stormwater from leaving the designated site. And the last option is you can route, if the project is a PDP and there are structural BMPs or enhanced site design BMPs, you can route the water to those locations. So that's BL6. So I'll move on to the next one. Next slide. Okay, so this is BL7. This is the last baseline fact sheet. This is the management of non-stormwater discharges. It's considered a source control BMP. The BMP IDs in this fact sheet are SCF, storm drain signage, and SCG, educational BMP signage. So this fact sheet discusses the management of non-stormwater discharges from entering the storm drain system. The SCF, the storm drain signage, is required at all stormwater conveyance system inlets and catch basins. Typical signage includes like concrete stamping or concrete painting, placards, etc. And then SCG is actually a new one that we put in there. We decided to incorporate it because we've seen it being used, types of BMPs. And so basically the fact sheet goes over 3 different types of educational signage. We're going to create a whole new fact sheet, but we decided to put it in this fact sheet just to try to streamline it and not make another BL8. But anyway, so it's incorporated into this fact sheet. And it goes over 3 types of signage. The first one is temporary BMP signage. You can see that photo on the left. It's just like basically a temporary sign that says, "Do not disturb this area." So hopefully contractors don't drive heavy equipment over a completed basin. This is a temporary measure that's removed once the project is stabilized. And the second educational signage is model home BMP signage. Just provide education to future homeowners of the benefits and responsibilities of BMPs on the property. So if there's a model home and you have a proposed BMP on the model home, there should be some signage so folks understand why that BMP is there and then understand their responsibility for maintaining it. And then the last one is this interpretive BMP signage. Just provides like a permanent educational BMP sign to the public on the benefits of the BMP. I've seen these used in the county. I went at my local Vaughn's of bioswales on that facility. When I went back east, I even saw it on Cape Cod. There was a sign of a BMP that was discharging into a bay and had a nice interpretive sign. So there's places where this type of signage may be appropriate for the public to understand why this BMP is there. Okay, so now I'll just go over the table 1 and 2 of the standard and PDP SWQMP forms. Yeah, so just a quick overview for some folks maybe that the county always requires a stormwater intake form for any new project. That stormwater intake form, you fill it out and then it determines whether you're a standard project or you're a PDP project. So if it meets any of the PDP thresholds in that second box, then your project's a PDP. And if not, you're a standard project. So here's on the left is the standard project template, and on the right is the PDP project template. We have these located, I think, in the link that Renee showed you above. They're available in Word, and they're also available in PDF format. And so I'm just going to be describing tables 1 and 2 and how these new baseline BMP fact sheets fit into the SWQMP forms. All right, so here's table 1 from the PDP and standard SWQMP. So as you can see, we actually streamlined these. In the previous table 1, we had a boxes for full and partial implementation. That seemed to cause confusion, so we stopped it. We eliminated that, and just one box you check if you're going to be implementing that. Incorporating that BMP into your project. You can always write in table 3 if there's any discussion needed that it wasn't fully implemented or not. So you can have discussion in that table if needed. As you can see, it flows kind of as a fact sheet flows. So if you look at A, it references fact sheet BL1. And on the left, you check the features that are on the site. And then you would check the BMP's ID that is used to mitigate those features. The BMP ID, again, the SDG, SDHs, those are all should be put on an exhibit or integrated into your plans. And same for the next one, B, it refers you to fact sheet BL2. On the left, the applicable features. And then, again, it gives you 3 options here to mitigate those features. And then on to C, rooftop areas, and again, it refers you to the baseline BMP fact sheet for more information. Then it gives you the options on how to mitigate if you have rooftop areas, what BMP you'll check. Then D, for landscape areas, we used to have, I think, 3 different options here. We had like efficient irrigation, and then native drought-tolerant plants, and something else, but now we decided to consolidate it all into this one concept of sustainable landscaping. Sustainable landscaping integrates all those into it. So now, if your project's over 500 square feet of landscape, you may have to do a landscape plan with your project. If not, then you can use the guidelines and the sustainable landscape guidelines to incorporate into your project. So that was for the site design BMPs, table 1. So Table 1 covers site design BMPs, and Table 2 covers the source control BMPs. We rearranged this table, and we kind of have a new way of filling this out. So A, management of stormwater discharges. Again, on the left, you say you identify all the work areas that are going to be incorporated into the project. And then you move to, so 1's identify all the work areas, then 2, which BMPs will be used to prevent materials from contacting rainoff or runoff. And that refers you to BL5, so those are the options to prevent materials from contacting rainfall runoff. So overhead covering, separation of flows, the berms and grade breaks, and wind protection. And then number 3 is where will the runoff be routed to? So that's BL6. Will be run to a sanitary sewer, most likely not, but a containment area, or is there existing stormwater BMP on site that this will be routed to? B, prevention of non-stormwater discharges. We streamlined this section. We made it pretty straightforward. Do you have storm drain inlets and catch basins? If so, you need to label them according to SCF. If you want to incorporate educational BMP signage into the project, and you would label it with educational BMP SCG. And then the other 3 are just, if they're proposed, then you're certifying in your design that they will not discharge directly or indirectly to the MS4 or receiving waters. So overall, these 2 tables have been streamlined, and now there's references for when people want to know a little bit more about these features. All right, and thanks, and I'll pass it back to Renee.
Thank you, Jeremy. That was a great segue into the source control and site design BMP requirements, which are listed in chapters 2 and 4. And that's really, like Jeremy said, that's one of the changes that we made that we're going to be going over is, Appendix C, which is the site design and source control BMPs, and how we changed a little bit the tables and how we are, counting those, so those things that are so important are not forgotten when you're doing whether a standard project or a prior development project. Next. Okay, so I'm not going to repeat too much of what Jeremy already said about, the definition of the baseline BMP, which is really anything that's required or applicable and feasible. And this includes both site design and source control BMPs. And some of them may be able to qualify for DCV reduction, but we're just going to focus on the bare minimum here, which is anything that you can do that is practicable and applicable and feasible to implement. All right, so one of the biggest changes here is, how we used to group them before into 4 different groups. This was in Chapter 2, of course. We had the groups were natural features on the left, common impervious outdoor features, other proposed outdoor features, and pollutant-generated features. Now we're pretty much ungrouping them like that and putting them into these other categories, which are the baseline BMP fact sheets, which is existing natural site features, outdoor impervious areas, rooftop areas, landscaped areas, work and storage areas, management of stormwater discharges, and management of non-stormwater discharges. So that's in a nutshell, that's what it is. How they were used to be in 4 groups, and now they're categorized in different based on BMP fact sheets. One of the changes that we made was Table 2-1, which we needed to include the new Appendix I. So we're doing this across the board, and anything that we can see, we're identifying. We're making the edit in this presentation. Anything that has to do with how we're adding a new appendix, or we're referring people to another location. So here's another definition. This one is about an enhanced site design BMP. This was already in the 2019 BMP Design Manual. And it says that enhanced design BMPs are those BMPs that are sized for crediting towards reduction in design capture volume, or DCV, for drainage management area, or DMA. These type of BMPs are actually credited in the worksheet B1 of the BMP Design Manual to partially satisfy DCV reductions or HMP reductions in the DMA. So this is the concept that was already there in Appendix B. The language was already in the 2019 BMP Design Manual, but now we're just bringing it back more to the front, so we can all see that this is, an important category that we should not disregard, because DCV reduction actually matters, and it helps you when you're ultimately sizing if you're doing structural BMPs, or if you're going to go with this other route that we're going to be introducing pretty soon. All right, so in Chapter 2, in Section 2114, we introduced again, a new worksheet. In this case, in Appendix I.11. This is an Appendix I, and we gotta make sure that when you're doing enhanced site design BMPs, that you can use Appendix B1 or Appendix I1. So in a nutshell, just reorganizing the information and getting a little bit of the BMPs are now in order. The tree well is SDA, the impervious area dispersion is SDB, and then we go to the green roofs, permeable pavement, green barrels, etc. So that's in a nutshell what this particular change is. All right, so we go to Chapter 4, and there's Section 4.2, and we have Table 2 that Jeremy just went over. So I guess the important message here is that if you happen to have small residential project, you don't have to fill out Table 2. Table 2 is really for the source control BMPs that are more like on the commercial sites, on the larger developments. So for small residential projects, this table doesn't really apply. So what is a small residential project? So a small residential project, what the county considers, is any project that that requires either a building permit, minor residential grading permit, or a site plan permit, or a tentative parcel map permit. So you can do for all of those for a single family home, or the tentative parcel map permit for up to 4 single family homes and a remainder parcel. So really small residential projects. All right, so again, we're keeping in Chapter 4, and this time Section 4.2.1, we needed to incorporate the new baseline BMP fact sheets, in this case for source control. So we just added language to incorporate the work and storage areas, the management of stormwater discharges, and the management of non-stormwater discharges. In Section 4.2.2, we talk a lot about stenciling, and in the past we focused a lot on just the regular stencils for catch basins. So now we're kind of like not redefining it, but just we're taking it an extra step, and now we also focus on adding the following type of BMP signage. We're calling it educational BMP signage, like Jeremy said, which includes a temporary BMP signage, the model home BMP signage, and the interpretive BMP signage. The temporary BMP signage is more like when you constructed a BMP and you want to make sure that it doesn't get disturbed while you are still doing construction. That's where you place those. The model BMP signage is more about if you happen to have a development with model homes, per the landscape ordinance, it is required to have some signage that will tell the prospective property owner or homeowner that they're going to have some landscape to maintain, and that landscaping may include some type of BMPs. And the last one is the interpretive BMP signage, which is more like on the permanent side of things as opposed to the previous two. This is more like for educational purposes and just to tell people what those BMPs are supposed to do. And you would see those on large public works projects. And then we go into section 4.3, which is site design BMP requirements. So we made the link again. So when you happen to have site design BMPs, which we also refer to as LID BMPs in some cases, we're making the link to these types of, these particular fact sheets, which are the existing natural site features, the outdoor impervious surfaces, rooftop areas, and landscape areas. So those are the four connections that we're making here in this particular section of the manual. So now we get into, we're still in the same section, but we're adding the whole concept about enhanced site design BMPs, and what does it mean? Well, it means that these are the types of BMPs that we consider enhanced site BMPs: the tree wells, the impervious area dispersion, the green roofs, the permeable pavement as a site design BMP, the rain barrels, and the amended soil. So these are all for you to get DCV reduction. That's really the goal. All right, so on the same line, following the enhanced design BMPs, now we get into the significant site design BMPs, which I will go over the definition. So the SSD BMPs, or significant site design BMPs, those are actually enhanced site BMPs, which are fully able to result in quantifiable flow control benefits. So we're featuring those in Appendix I-1. So not to confuse everything, but we talked about baseline BMPs, which are featured in Appendix C, which are the bare minimum, site design and source control. And now we get into the Appendix E, which includes an update to the table. So the update to the table includes, how we're labeling them, which ones are the enhanced site design BMPs, which ones are the structural BMPs, and which ones are significant site design BMPs. So let's start with the enhanced site design BMP. So those are on the very top, the ones that are for DCV reduction. Structural BMPs are those that are intended to meet pollution control and or flow control. And you also have flow through treatment control, which is something that is used for some type of projects, and also per the previous requirements of SWQMP. And then lastly, we have an asterisk there on two types of enhanced site design BMPs, which are the tree wells and the impervious area dispersion. So those two can function as significant site design BMPs when sized according to section 523. And there's also plenty of language about this in the new Appendix I. And now we're going to get into the Q&A, and we're going to, look at some of the questions that have been submitted.
Thank you, Renee and Jeremy. Let's give Renee and Jeremy a virtual round of applause. Thank you. That was great. So we have quite a few questions. We've got 5 minutes slotted for questions, so we will try to get through as many of those questions as we can. And I'm sorry, we have 15 minutes for questions. So our first question is, will the PowerPoint be available after the presentation? And yes, it will be. As I mentioned earlier, we are recording this presentation, so you'll have a recording that has the PowerPoint and the audio, and that will be available after the presentation at a future time. And thank you also, Brian Smith, for asking if the recording will be made public, and yes, it will.
There will be two parts of the answer to that question. So one of them is the PowerPoint slides. Those will be also available on the county website under the development resources page under the category of training. And then also the recording will also be made available in the same location. So there will be two links, one for the PowerPoint slides and one for the recording.
Great, thank you, Renee. All right, so now we'll go on to our technical questions. And we've got a couple pool questions that I'd like to ask. Is there any freeboard requirement for the pool? And another question related to pools are, why are pools no longer exempt? What was the rationale behind this? pools are routed to the sewer system, not the MS4?
Okay, I can briefly answer both of them. There is a freeboard requirement, but I don't know what it is for the county because I don't process building permits. But we will get back to you on the, if we have the name of the person who asked the question, then we can actually get back to them as to what is the specific freeboard requirement for any swimming pool. The other part was, what was the, I guess, the rationale. So the rationale was that there was a meeting with the regional board, and there was a request made that that language be removed to the exclusion language about swimming pools and other water features. As a result of that request from the regional board, the model BMP design manual was updated May of this year. And then obviously the county BMP design manual has incorporated that revision also with this current September 2020 update. And the last part of the question was about pools and sewer lines. So if you recall, there was a slide from Jeremy about all of the sewer jurisdictions. So the goal is to consult with your sewer jurisdiction to make sure that you can discharge to the sewer line. So you can discharge a swimming pool into the sewer line, because not all sewer agencies are willing to accept that type of runoff for a number of reasons. So that's the goal. You need to check with your sewer agency to make sure that it is accepted. If it is accepted, then you can do that. If not, you got to find other ways to do it.
Thank you, Renee. Our next question comes from an anonymous attendee. Is 2-inch minimum freeboard, as stated in the BMP manual, enough to handle flood control requirements if the BMP is in line and is being used for both pollutant and flood control?
So the best way to answer is to look at the conjunctive use handout that I referred to in the presentation, and also look at the hydraulic design manual from the county, and make sure that you're following whatever specifications are in there about the, what the minimum freeboard is. There's some reference as to, what would be the minimum. So I don't recall the specific number, but you can refer to those two particular publications, the conjunctive use handout or the county hydraulic design manual.
Laura, Henry, can I contribute to this answer?
Yes.
The quick answer on the 2 inches minimum freeboard is that it is not enough to handle flood control requirements if the BMP is in line and being used for both pollutant and flood control. When the BMP is used only for water quality and it's not a conjunctive use BMP, if it's just for water quality and the high flows bypass the BMP, then 2 inches minimum freeboard is appropriate for making sure that the water quality performance of the BMP is as expected. But once we start processing all of the runoff as flood control through the BMP, then we need to look to the hydraulic design manual for the freeboard requirements. And based on the hydraulic design manual, the freeboard will be 1 foot.
Okay,
Thank you.
Thanks, Renee, and thank you, Laura. And just as a reminder, if you all could please put any questions you have in the Q&A and not the chat. And unfortunately, there's just too many attendees. I know that some of you are raising your hand and using that raise your hand function, but currently we're having to just monitor the Q&A session, and that's where we'll be taking as many questions as we can with the time allotted. So we've got 3 more minutes to get through a couple more questions. So from another anonymous attendee is, can filter layer be used for storage and HMP analysis?
Okay, I'll defer to Laura for that one.
Thank you. I'll take this one. And the answer is yes. In the HMP analysis, you're going to use the aggregate storage layer and the filter layer and the soil layer and any surface ponding, and all of that is available to be counted in the HMP analysis. So it's only in the flood control analysis that you have to exclude the soil and the choker and the aggregate and anything that has to travel through soil to get out of the basin. But for HMP, we do get to include all of that volume.
Thank you, Laura. And our next question comes from Chris Corey. I am curious of the county's recommendations for compaction around BF1 basins with impermeable liners, therefore no infiltration?
I'm not sure I can answer that question. So if the BMP is a biofiltration, it's going to have an impermeable liner. So I'm not sure if the question is about the compaction under the liner or on top of the liner. So I guess, I don't know if Laura, if you want to chime in on this one.
So my understanding is that BF1 might, so a BMP may need to be classified as BF1 if water can't infiltrate due to either an impermeable liner or simply having compacted soils around it. I think we don't necessarily always have to have an impermeable liner on a BF1 because sometimes just the native soils themselves are impermeable, but you have to classify it and size it as BF1 if either you have an impermeable liner or the soils surrounding it are so impermeable that you have no infiltration. I hope that answers the question.
Okay, thank you,
Thank you.
Laura. And our next question is 30 mil liner, any other requirements, tensile strength, etc.?
Unfortunately, this is the only thing that we wanted to add as a clarification because there was no information anywhere in the manual. So for now, that's all we're going to be adding. If there's a need to be adding additional information, we'll go ahead and add it at a future time, such as the tensile strength, etc. But for now, it's just the thickness is the only thing that was important, or at least was considered, to be adding into this current update.
Okay, thank you, Renee. Well, we have now hit our break time, and so we'd like to take a quick break from 10:05 to 10:10. And we do have quite a few questions, so if we have time at the end of the presentation, we'll be more than happy to continue to answer these questions. What we'll do is we'll start a new session of questions for the next round of speakers, and we'll address those questions at the next Q&A. So go grab your drink or a snack, and we'll meet you back here at 10:10. Thank you. Okay, well, welcome back, everyone. And I'd like to now hand the presentation over to Laura Henry, who's going to discuss the new Appendix I.
Thank you, Jane. Hello, everyone. I'm Laura Henry from Rick Engineering Company, and I will present the new Appendix I that's been added to the county's 2020 BMP Design Manual. The new Appendix I is dedicated to the design of significant site design BMPs, or SSD BMPs. And this appendix will present design procedures for dispersion areas and for tree wells as SSD BMPs. So as Renee described earlier in this presentation, SSD BMPs are site design BMPs that are sized and constructed to fully satisfy PDP requirements for pollutant control and hydromodification control. So first of all, they fully satisfy the design capture volume for pollutant control. And then second, if your site is subject to hydromodification management requirements and hydromod control is required, then these BMPs can be designed with greater criteria to satisfy the hydromodification control requirements in addition to pollutant control. So this means when you can meet these requirements, you would need no additional structural BMP downstream of these BMPs. They can take that PDP requirement for structural BMPs as a site design BMP. So I'm going to try to clarify the categories of site design BMPs in a couple different ways, since I know we're starting to use this name in many different ways. And it's because we now have a couple of different implementation levels for the site design BMPs. Under our MS4 permit and under Chapter 4 of the BMP Design Manual, certain site design practices are always required to be considered for a site, and it includes some practices like impervious area dispersion. And we need to implement them as much as feasible, wherever there's feasible, and we don't really have a minimum size that we have to meet in order to implement them. So as in, if we have a small size or a limited area, that doesn't rule out or preclude their use. As a baseline BMP and as the baseline implementation, we need to consider it and apply it wherever it's applicable and feasible. The site design practices, they do have some design recommendations, and when we can meet the certain minimum sizing and design requirements, implementation of some of these site design BMPs can reduce the overall design capture volume that has to be managed for pollutant control. This is what the county calls enhanced site design BMP. If you meet the minimum sizing and design requirements, it can reduce the total design capture volume that's draining to a structural BMP. Significant site design BMP is the next level. We have greater design criteria, and when we can meet these greater design criteria, the significant site design BMP can fully satisfy the DCV and hydromod requirements. And at that point, you would then not need to have an additional structural BMP downstream. Next. So the BMPs that are listed on the left of this table are all site design BMPs that can be applied as enhanced site design BMPs to reduce the burden on a downstream structural BMP like a biofiltration BMP. And then some of these BMPs at the bottom of this table, they can be designed as significant site design BMPs and fully satisfy the PDP BMP requirements and not need a structural BMP downstream. Next. So some of you have been practicing for several years and have already implemented some of these practices that I'm talking about might be wondering exactly what's new about this. So I want to clarify a timeline of the standards and also try to be clear about what some of this is unique to the county versus some of this is coming from the Model BMP Design Manual and is applicable in other jurisdictions. So we'll start with 2016. The 2016 Model BMP Design Manual for all of the co-permittees provided criteria for site design BMPs to reduce design capture volume. And the County of San Diego adopted the design options from the Model BMP Design Manual, and also the County of San Diego removed the upper limit of how much design capture volume could be managed by a tree well. So in the county's local BMP Design Manual in 2016, you could satisfy more than I believe the model had a limit of 25% of the DCV being satisfied by a tree well, but the county had removed that limit and allowed for a greater amount of the design capture volume to be satisfied by a tree well. At that time in 2016, nobody had any sizing criteria available for the site design BMPs to satisfy hydromodification management. In 2018, the Model BMP Design Manual for all of the co-permittees was updated to add criteria for impervious area dispersion to satisfy hydromodification management. And at that time on their own, so concurrently with this, the county was preparing their own modeling backup to make design criteria for the tree wells to satisfy hydromodification management. So with their 2019 BMP Design Manual, the county adopted the impervious area dispersion criteria that was created for the Model BMP Design Manual, and they also included the design criteria that they had created for tree wells. Also in 2019 is when the County of San Diego introduced their terms of enhanced site design BMP for a BMP that partially satisfies design capture volume requirements and significant site design BMP for a BMP that fully satisfies design capture volume. So here we are now in 2020, and in 2020 we don't actually have new design criteria being added, but what's new is we've created an appendix that has step-by-step design guidance in order to help with the design of the SSD BMPs, and a spreadsheet tool has been created to facilitate that design. So under the county's 2019 BMP Design Manual, the guidance to design SSD BMPs was presented in the fact sheets for the BMPs in Appendix E. Now in 2020 manual, we're still going to use the fact sheets from Appendix E, but we also have step-by-step guidance in Appendix I, and we have the new spreadsheet tool. So I'll continue discussing the Appendix I. I'll continue discussing the contents of Appendix I, and then later in this presentation, Renee will present the spreadsheet tool, and Renee and I will run through an example problem. Okay, what is impervious area dispersion? I think a lot of our audience is very familiar with this, but we do have somewhat of a diverse audience today, so there will be some that I'm going to go over this for. Impervious area dispersion refers to the practice of dispersing runoff from impervious area across a pervious area before collecting it into a storm drain system. It's a really good way to manage runoff from rooftops, patios, parking lots, walkways, or any other area where the runoff can drain off the edge of the impervious area as sheet flow. The dispersion area refers to the dedicated pervious area that receives the runoff from the impervious area. So in the dispersion area, we have soil capable of infiltrating some of the runoff, and the dispersion area has vegetation that slows the runoff, giving it time to get into the soils and be infiltrated. The design elements that we consider for dispersion areas that have the criteria defining their performance as an SSD-BMP are the ratio of the impervious area drawn to the pervious dispersion area, the surface soil type in the dispersion area, the length that runoff travels across the dispersion area as sheet flow, and the slope of the dispersion area. This table is provided in Appendix I, and it summarizes the criteria for impervious area dispersion as an SSD-BMP. And it summarizes it in terms of what's required for handling pollutant control only versus what's required for handling pollutant control plus hydromodification control. So on the lower half of the table, you can see that the criteria for the travel length and the slope are the same. The difference is when you want to use this for pollutant control only versus pollutant control plus hydromodification control are the maximum allowable ratio of impervious area draining onto pervious area and the type of dispersion area surface that's allowed. So for hydromodification control, the surface must be an engineered pervious surface, and it needs to have at least the top 11 inches of soil using amended soil based on fact sheet SDF. This is a summary of different types of pervious surfaces that are typically considered for dispersion areas. You can disperse runoff across natural or native soil without applying any soil amendment, but for that case, only the hydrologic soil group A or B can be used as an SSD-BMP, and only for pollutant control. Hydrologic soil groups A and B are the types that naturally infiltrate better. Hydrologic soil groups C and D will infiltrate some, so they can get you some credit as an enhanced site design BMP towards reducing design capture volume to a downstream structural BMP, but they can't get you full credit an SSD BMP. Now, if you amend the soil in accordance with the county's fact sheet SDF, no matter what the underlying native soil is, once you amend it, it becomes engineered pervious surface. And so you can consider it as, you can look at the runoff factor for engineered pervious surface and you can classify it as that. And in that case, it can be used as an SSD BMP for pollutant control. And then if you ensure that the amount of the thickness that you've amended is going to be at least 11 inches thick, then you can use it for pollutant control and hydromodification control. And the reason for the 11-inch requirement is that's based on the continuous simulation modeling backup that was prepared in order to develop the criteria for using a dispersion area to meet hydromodification control requirements. Finally, sometimes semi-pervious surfaces are being used in dispersion areas. A semi-pervious surface, such as cobbles or crushed aggregate that is not a vegetated surface, it can get you some credit towards reducing design capture volume as an enhanced site design BMP, but it cannot be used as a significant site design BMP. The final notes on dispersion areas: if you can design them to meet the SSD BMP criteria, then you will not need an additional structural BMP downstream of them because the dispersion area will provide enough retention and mitigation of the runoff to meet the PDP requirements. Now, if you can't meet the SSD-BMP criteria, don't let that stop you from applying impervious area dispersion on the site, because you can potentially size it to get some credit towards reducing the burden on a downstream structural. And even if not, keep in mind that the practice should still be considered and applied to the extent feasible as a baseline BMP. Okay, that's all that I have on dispersion areas. We'll move on to tree wells next. A tree well is a stormwater management feature that includes a tree, and the tree planted in a minimum designed volume of soil media. And this configuration allows for storage, infiltration, and evapotranspiration of runoff. The key design elements that we look at for the tree well are the tree and the volume of the tree well soil. This is an excerpt of a table that's provided in Appendix I, and it summarizes the criteria for tree wells as either pollutant control only or pollutant control plus hydromodification control. On the bottom of the table, you can see that the design for the soil volume is going to be the same. So the key difference shown at the top of the table is how much tree credit volume you're going to need. You'll need to have trees with a larger tree credit volume or use more tree wells in order to satisfy hydromodification requirements. I think of the tree well design process as a cycle because it's going to include coordination back and forth between the civil engineer and the project landscape architect to agree on the trees to be used and to agree on the layout. My next slides are going to walk through the steps that you see on this slide, which are the initial tree selection, getting the design capture volume, and then, if necessary, getting the required retention volume, confirming the number of trees, and then getting the dimensions and the spacing of the tree wells. So the process should start with discussing the tree options with the project landscape architect. We always want to make sure that the stormwater engineer doesn't submit a design that's inconsistent with the landscape plan for the site. And to get this discussion started with the landscape architect, there's a tree palette table provided in fact sheet SDA and also copied into Appendix I that lists the tree species and the sizes for the tree wells as SSD-BMPs. Now you can use other tree species that are not listed on this table at the discretion of the county landscape architect. So once we've cleared with the landscape architect that we're intending to use tree wells to manage the stormwater, we need to determine the amount of stormwater that needs to be managed. For each drainage management area that's using tree wells, we calculate the design capture volume for pollutant control, just the same as if we were designing a structural BMP such as biofiltration. Now, if hydromodification management is required, we're going to increase the design capture volume by a factor we call the DCV multiplier, and the result is called the required retention volume, or RRV. The RRV is the total tree credit volume that it would take to satisfy both pollutant control and hydromodification control together. And to be clear, the DCV for the pollutant control is encompassed within the RRV. So we don't have to add them together. We would just need to get the RRV, and that's the total amount of the tree credit volume needed. The DCV multiplier table is based on the continuous simulation hydrologic modeling that the county prepared in order to come up with the design criteria. The table is provided in both fact sheet SDA and Appendix I. So here are some notes about using the DCV multiplier table. You'll need to know the underlying native hydrologic soil group A, B, C, or D from the pre-project condition. Then you want to select the multiplier, the DCV multiplier, from the standard tree well depths that are presented on the left-hand side of the table, 30, 36, 42, or 48 inches. The minimum depth is 30 inches, and this is because the tree well soil has to be installed to at least 30 inches depth according to fact sheet SDA. There's no requirement to interpolate multipliers between the standard depths. If your actual depth is not shown, you can use the multiplier for the next lower depth, as long as the depth that you're installing is at least 30 inches, because the soil has to be at least 30 inches thick. After you have the DCV or the RRV, depending on which one you needed, again, DCV for pollutant control only, or RRV for pollutant control plus hydromodification control, Your next step is to determine how many trees you need to satisfy the volume. Each tree species has a given credit volume that's shown in the right-hand column of the tree palette table. The number of trees that you need is your DCV or RRV divided by the given credit volume for the tree that you and the landscape architect agreed on when you started this process. If you need to at this point, you might want to revisit the landscape architect and make decisions about whether to use multiple 10-foot canopy trees versus one 20-foot canopy tree. Now, once we finalize the tree selection and the number of trees, the next step is to design the tree well soil volume. And at this point, the tree well soil volume is not based on the DCV or the RRV. It's actually just based on the size of the tree. So based on fact sheet SDA, the tree well has to have a minimum of 2 cubic feet of soil volume per square foot of mature tree canopy projection area. We get the tree canopy projection area based on the tree's mature canopy diameter, which is presented in the tree palette table. And then we multiply that by 2 for the 2 cubic feet of soil required per square foot of canopy area. And then we know the minimum volume of soil that we need to have in the tree well. Knowing the minimum volume of soil that we need and knowing the depth that we intended to install it, we can divide the volume by the depth to get the area of the tree well soil installation. And you can configure this in many different ways. It could be in a circular pit, or it could be in a square or a rectangular excavation. There are some factors to consider. The tree well soil needs to be installed within 1.5 times the mature tree canopy radius. So we don't want to have that tree well soil extending too far away from the tree. It needs to be close to the tree. This will be important if you're trying to have a rectangular tree well extending parallel to a street, like in a parkway. You'll need to make sure not to tighten up the width so much that the length extends outside of 1.5 times the tree canopy radius. If you're using multiple trees, each one of them needs to have its own minimum soil volume. And so the trees would then have to be spaced so that the volumes don't overlap. And then, of course, your landscape architect might have other factors for you that you need to consider that influence the spacing of trees. So make sure to coordinate with the project landscape architect. Some final notes on the tree wells. As SSD BMPs, they do not need an additional downstream structural BMP because they provide the required retention and flow mitigation. If you can't design it as an SSD BMP, you can still try to use it as an enhanced site design BMP to reduce the burden on a downstream structural BMP. And of course, trees should always be considered for a project because the benefits of trees are much broader than just stormwater management. That concludes our discussion of tree wells. Next. So these next 3 slides will present areas that the body of the BMP design manual was amended to accommodate the SSD BMPs and allow for their use. And then following these 3 quick slides, we'll have a question and answer session and then another 5-minute break. And then Renee will present the new spreadsheet tool that was created to help you design the dispersion areas and the tree wells. In Chapter 5 of the BMP Design Manual, we've had edits to add the SSD criteria, to add references to Appendix I, and to clarify that SSD BMPs meet PDP requirements and do not need structural BMPs downstream. And also we have a little discussion of what to do for hydromodification analysis if the project is using some SSD BMPs. Chapter 6 has been updated to allow SSD BMPs as an option for satisfying hydromodification control requirements. The new text on page 611 clarifies that if you design SSD BMPs according to their design criteria, you will not need to have a continuous simulation analysis. Finally, appendices B and G have had text added indicating that SSD BMPs can be used to satisfy the requirements for pollutant control and hydromod control. Thank you. And now we can take questions from the audience.
Great. Thank you, Renee and Laura. Appreciate that presentation. So we have lots of questions and we have until 10:55. So we'll try to get through as many of the questions that we can up until 10:55. So we'll start off with an anonymous attendee asked, The checklist approach of the baseline BMP section of the SWQMP form seems to indicate the project design rather than providing a tool to achieving compliance. This approach leads to reviewer discretion. If my project is providing a retention BMP or a capture and reuse facility, why am I required to consider BMPs which are infeasible for most sites, i.e. green roofs, rain barrels, or impervious area dispersion?
I can answer, and then maybe I can have Jeremy add a little bit more to it. So the checklist was revised to make sure to capture, as many baseline BMPs as are applicable and feasible. There's always a section in each of the templates which says that if any of these BMPs are infeasible or some other reason, then there is a place for that explanation to be made. So again, it's trying to include as many of those type of baseline BMPs, site design or source control BMPs as applicable and feasible on a project. And if there's some infeasibility or impracticality or anything else, then there's a section where you can document why that particular type of BMP is not being proposed in the project. Jeremy, do you want to add anything to this?
No, I think you captured it pretty well. You can always, if there's a table 4, you can use that table to kind of clarify how you implemented a different BMP.
Thank you.
Can I add to this that even when we are using a structural BMP to retain runoff, implementing site design BMPs upstream of the structural BMP will reduce the burden on the structural BMP. So that's where we start at the source, and implementing the site design BMPs reduces the runoff. So we're starting at the source rather than relying on the end of the line treatment. So that's why we still have to consider some as baseline, even if we are going to provide compliance with a retention BMP. We want to reduce the burden on that retention BMP. It'll also reduce the maintenance requirements on the structural BMP if we can apply site design upstream to minimize what gets into it. Thank you.
Thank you.
Great. Thank you. And our next question, can we use baseline BMP permeable pavement as a 0.1? Same for baseline landscaped areas, 0.1?
Yes, that is correct.
Okay, great. And thank you, Ray, for answering or following up on Chris's question. We appreciate that. And our next question is, can dispersion be lined if thickness of the landscape if 11 inches is met?
Yeah, it's an important question, I know, because we've got to look at where that runoff goes, but the basis of the dispersion area being able to meet the requirements is that it's going to actually remove runoff, so it cannot be lined.
Any follow-up, Renee?
No, that's pretty much the answer that I was going to give. Thanks,
Okay.
Laura.
All right, and then our next question is criteria for dispersion areas as SSD BMPs. How do you confirm the length of flow is flowing in sheet flow or similar? Do you lean on the hydrology manual table for soils, cover, and slopes?
What we want to look at in order to confirm that the runoff will go across the dispersion area as sheet flow is we want to look at the site plan and grading plan for how that runoff is delivered to the dispersion area. And what we're looking for is to see that we don't have it discharged just at a point and have it conveying straight across in a channelized manner. So some ways, if you have a sidewalk or a patio, you can probably just have the runoff drain right off the edge. If you have roof drains, which do have, which in a way they create points, but you could put what we call a level spreader along the edge of the dispersion area and allow the runoff to spread, say, through some rocks that get it across So at the upstream end of the dispersion area, it's dispersed along the width of it, and then it's released in a sheet flow manner out of the level spreader and down the dispersion area. So you'd be looking at the grading plan, how the grading is laid out to allow the runoff to go in sheet flow.
Great, thank you. And the next question is, do the Appendix I and significant site design changes only affect projects under county jurisdiction? Do you know if other local jurisdictions will be adopting similar criteria?
I don't know the answer to that. We have presented, the county approach to the co-permittees at previous meetings, and they have had some, really good discussion and really good questions. I'm not aware of any other jurisdiction adopting this particular methodology, just because it means that you have to update a manual, kind of like the county has. So again, that would be up to each and every individual jurisdiction if they want to go ahead and go through that process like the county has.
Great, thank you, Renee. And we've got a curious anonymous attendee is asking, is a non-engineered pervious surface the same as natural soil?
Yes. So a native soil or a cut soil. So a fill would be an engineered pervious surface, but a cut could be it would be considered the native soil, or just simply an undisturbed area of native soil.
Great, thank you. And Min GC is asking, are there any ponding depth and drawdown requirements for amended pervious dispersion areas?
No, they are not required to have ponding. It's assumed in the design of these, it's assumed that they will have a positive slope. So that's not to preclude ponding. You could have some ponding and retain runoff that way, but it's not required for the dispersion area. In fact, the BMP design manual even allows up to a 5% slope, although that's awfully steep. You'd have to consider making sure that you didn't have erosive conditions. But if you had a typical 1% or 2% slope and did not have ponding, that would be fine as long as the runoff has at least 10 feet of travel length.
Okay,
Thank
great.
you.
And then are there minimum design requirements for soil media?
If we're talking about the soil media for the dispersion area or for the engineered pervious surface, we can refer to the county's fact sheet SDF in Appendix E, and that provides the discussion of how the soil should be handled.
Okay, great. And Nicole Fine is asking, how would you model SSD BMP in SWQMP? Or just omit that calc entirely, both tree wells and dispersion?
So the purpose of producing these sizing factors for tree wells and obviously for dispersion areas was to avoid having to model those particular drainage management areas in SWQMP or SDHM or any other continuous simulation modeling software. If there's gonna be some modeling regardless, then you have to account for a number of things. So I'll have Laura chime in if we're gonna model these type of BMPs.
Okay, thank you. So as Renee said, it's intended that you don't have to model these in SWQMP. So as long as it's designed hydraulically separate from other areas that might be not handled by SSD BMPs, if the drainage, any overflow from the SSD BMP is captured into the storm drain system and connects after other structural BMPs so that it's hydraulically separate, then in that case, you could actually omit them from the SWQMP analysis. If the overflow from the SSD BMP does drain and continue on into a structural BMP that's handling other portions of the site, then unfortunately you can't really remove it from the analysis because it doesn't infiltrate all of the runoff. It will have runoff. So what you'd have to do is assume it to be a landscaped area in SWIM, and for the tree well, you might consider using a stage storage discharge curve to model the volume of soil for the tree well.
Okay, great, thank you. And the question also asked, will we be providing seminars for these calculations? That may be a future seminar, so it could be a topic, so thank you for that. And then Sean is asking, credits for significant site design dispersion areas are based on hydrologic soil group classification. Is there a way to base the credit on site-specific infiltration testing if testing shows greater infiltration potential than what is typically based hydrologic soil group soil mapping?
So I'll go ahead and give the quick response as to, the intention of the SSD BMPs was to simplify and use some predetermined hydrologic soil types and their characteristics to come up with the sizing factors. And then once you have the sizing factors, you can just, do your calculations fairly quickly. If you're trying to use site-specific infiltration rates, then obviously there's another route you can take, which is, modeling everything through using continuous simulation modeling. Laura, you want to add anything?
Actually, I concur. That's what I would have said.
Okay, thank you.
All right, thank you. And then was all DCV multiplier backup modeling performed using the SDHM model or another hydrologic model engine, for example, SWIM, NetStorm, or similar?
Yeah, the answer to that is it was SWIM modeling that was done to come up with the sizing factors for tree wells.
Okay, great. And Mike McSweeney is asking, explain why multiple trees may be better than one large tree.
The quick answer is, I guess, if you have a cluster of 3 trees and one of them dies, it's easier to replace one tree, and in the meantime, you're not affecting the performance of the cluster of trees a whole lot, and you're just reducing it. But in the meantime, until you replace that tree. But if you have only one tree and that tree dies, then you no longer have a functioning BMP. Laura, you want to add to that?
I think it also depends on, because stormwater management isn't the only factor that's being considered when trees are selected for a site. You also have considerations for what you can handle for the tree canopy if it's close to a street. So the landscape architect will certainly want to have some input as to whether you're using large trees or multiple smaller trees.
Great, thank you. And we've got an anonymous attendee is stating, it is interesting that the SSDs are provided as DCV reduction. Has the county performed storm event runoff water quality testing to validate the performance of SSDs in meeting permit criteria for water quality reductions?
So this is similar to the previous question as to has any modeling been done to come up with the sizing factors, and the answer was yes. For the tree wells, the county did the modeling to come up with the sizing factors using SWIM, and for the dispersion areas, I believe that was done by the co-permittees as a joint effort to come up with the sizing factors for dispersion areas.
Great, thanks, Renee. And our next question is, can tree wells have under drains when on type D soil to control the time the water ponds on the surface?
So we're talking about using the sizing factors for SSD BMPs. So that is one of the disclosures that if you're using the sizing factors, you are not allowed to have under drains. If you want to have under drains for tree wells, then you're supposed to use continuous simulation modeling. And then I'll let Laura chime in for the rest of the question.
I think that's all that I had, is that there's no under drain in the continuous simulation model backup.
Okay, thank you.
Okay. And then Emily is asking, you mentioned that there is a list of acceptable trees for tree well design, but that other species might be acceptable at the county's landscape architect's discretion. Is there any list or information on what other species have been accepted in the past?
No, we don't have a list. But the idea is that if we do need to update this table, we will in the future. But no, we're not keeping a list. But there'll be more on this topic in the future.
Great. All right, and Sandy Brady is asking, is there road grade restraints or accommodation for drains related to tree wells constructed in roadway parkways? We have had problems with trees and parkways overflowing back to the road during large storm events on steeper roads with no tree well drains.
All right, so the quick answer is, like any other type of BMPs that we're talking about, stormwater BMPs are mainly sized for, a lesser year storm. It's not designed for the 100-year like, other features. So they can only take so much, and then they have to obviously discharge somewhere once they reach their capacity. Laura, do you want to add to that?
I would like to add that the tree well modeling assumes that the tree well is installed flat like a bioretention basin. So if you do have a steeper slope, the tree well itself probably needs to have check dams around it that create a little bit of a flat ponding area.
Great, thank you. And then Eduardo is asking, can we overlap tree wells? Previous BMP design manual allowed a certain percentage of overlap.
Yeah, I'm not sure if there was that specific language in the manual to allow overlap, but because we updated all these language and we added the Appendix I, and now we have a lot more criteria. The new criteria that we're publishing is the one that is, allowed moving forward, and also the spreadsheet tool itself tells you what the minimum separation is between trees. So, in overall, I guess you're not supposed to overlap. Just go through all of the criteria that is listed in Appendix I and in the tool itself.
Great, thank you, Renee. And then what is the criteria used to define sheet flow?
So with the sheet flow, again, what we're looking for is to not have channelized flow. So we're looking to see that the grading plan will allow the flow to use the full width of the dispersion area. So if we assume that it arrives along the width of the dispersion area and then it travels across the length, we want to see on the grading plan that runoff is allowed to arrive across the full width rather than being in points that could start to become channelized through the dispersion area.
All right, and we have time for one last question, and it is a follow-up question to the dispersion area that was previously answered. You indicated that the area dispersion cannot be allowed if the soil is lined. However, we have previously been allowed to do this in order to meet retention criteria, since it still provides evapotranspiration area. Can you please clarify if the dispersion can be allowed to meet the retention credit only?
Is this in regard to, I wonder if this is in regard to needing a minimum amount of landscaping on site when you have a biofiltration or bioretention BMP that is not at least 3% of the site area. And if that is the context of the question, then I believe a lined dispersion area could contribute to meeting that requirement. It would not be a significant site design BMP.
Correct. So DCV reduction, but not fully complying with requirements of both pollutant control and flow control, right?
Okay, well, great. Thank you all for your questions. Keep them coming, and thank you, Renee and Laura, for your responses. It is now 10:56, so how about we take a 5-minute break and we'll meet back here at 11:01. All right, welcome back, everyone, and it's 11:01, and now I'd like to hand the presentation over to Renee, and he's going to share with us the significant site design BMP tool. And Renee?
Thank you, Jane. Welcome back, everybody. I'm just going to give you some highlights of the Significant Site Design BMP tool, also known as the SSD BMP tool. This tool was released in August of this year, around August 15th, I believe, and the goal was to pretty much document everything that when you're using this particular pathway, and make it easy for somebody who's putting together the calculations. So just as background, back in January 2019, that's when the county allowed this pathway of SSD BMPs. We released the sizing factors for tree wells, and we took advantage of the sizing factors for dispersion areas that were previously released, and we put additional guidance in the 2019 manual, but apparently that wasn't enough, so we decided to go ahead and standardize the process with this particular tool that you're going to see that just documents everything and makes it easier to put it all together in the stormwater management plan if you happen to be a priority development project and wants to use this particular pathway. Next. So we're using these particular two figures that are the tree well figure and the impervious dispersion figure. And you're going to see these two figures across the board in a number of different slides moving forward. So it just gives you the parameters where you have to take into account where you're designing one of these type of SSD BMPs. So again, tree well and impervious area dispersion is what we're going to be talking about moving forward. So just to illustrate what the two different pathways are, if the conventional pathway that you've been using for structural BMPs is shown on the one on the left, and it hasn't really changed. We released the templates, the PDP SWQMP templates, the standard SWQMP templates, and the attachments back in January 2019. So it's already been almost 2 years since they were revised and implemented. So if you're using the pathway of structural BMPs, it's what's shown on the left here. You have your PDP SWQMP, or Priority Development Stormwater Quality Management Plan. That's 14 pages long, and then you have all those attachments that you need to include with it. If you happen to use this new pathway, or this pathway that was started in January 2019, you only have to fill out the PDP SWQMP, the 14 pages, and the attachments that are listed on the right. Now, one important thing to mention here is that the pollutant control and the flow control attachments are no longer required because you have attachment number 6, which takes care of the drainage management areas that don't use structural BMPs. They use significant site design BMPs. So the other thing to mention, you don't require a registered professional engineer if you're using the pathway on the right. So in other words, the applicant will sign the PDP SWQMP, and there will be no attachment with the structural BMP to sign for a registered engineer. So if you're using the pathway on the right, again, you don't need a registered professional engineer. This is what the 4 different tabs of the tool look like at a glance, and also the 2 figures that we'll be referencing moving forward. So the tool is made it's comprised of 4 different tabs. Now, one thing to remember is that there's other tools out there. There's the pollutant control spreadsheet or tool, and that one is to comply with Appendix B of the manual. We also have the BMP sizing calculator, also known as the BMP sizing spreadsheet, and that one is made to comply with Appendix G of the manual. And now we have this new tool that replaces both of them. So if you're using this particular tool, the SSD BMP tool, you don't need to fill out the Appendix B worksheet or the Appendix G worksheet. The other thing that's important to remember is that the colors, we made the colors a little different so you could tell which one you're using. In this case, there's a lot of green in this particular tool, so just remember that the spreadsheet with the green cells, different shades of green, is the one that is the SSD BMP tool. All right, so we go into the introduction tab, which has a welcome message and it has some instructions. So in the welcome message, we have, the use of this tool is you know, it's to meet compliance with the MS4 permit. We also have, you know, to reminding people to make sure that you're using the most current version of the tool. In this case, the version we release is 1.0. And we also have a line item that says, you know, this tool is not really intended if you're going to use structural BMPs. If you're going to use structural BMPs, there's other tools that you're going to use. So you're only going to use this tool for when you're using the impervious area dispersion pathway SSD-BMP or a tree well pathway SSD-BMP, and you can also include other types of dispersion in there. And along the instructions, that tells you, the paragraph tells you more or less what those different colors mean. What you're going to be looking for is the light green cells. So the light green cells are where you do the majority of your inputs. The dark green, or you know, fluorescent green is what I like to call it too, is that those cells get automatically populated depending on your inputs with the light green cells. The gray cells are those where you don't enter any information. Those become blocked depending on what your inputs are in the light green cells. And then lastly, your white cells are all of your results, all of your outputs. You might get some orange cells here and there, and those will be warning messages. One other thing to remember is that this tool is, you know, each particular tab can only hold up to 10 DMAs. So if you have more than 10 DMAs in your project, you can just use open up another spreadsheet and print it separately. All right, so along with the intro tab, we also have a little bit of a paragraph for each of the steps. For example, step number 1 is where you do all your inputs to determine your design capture volume. This one has a lot of information that's important because that will determine, you know, your next steps. Step number 2 is where you enter your dispersion areas. And some people may decide, no, I don't want to use dispersion areas as an SSD BMP. So you just go directly into step 3, and then you do the rest of your inputs there to make sure that you are fully compliant with both pollutant control and flow control. All right, and at the end of the tab, there's a disclaimer, you know, similar disclaimer like all of the other tools that the county has produced, you know, and, you know, you use this sort of like at your own risk. So this tool is made to comply with PDP requirements, and in order to meet MS4 permit requirements for prior development projects, et cetera, et cetera. Make sure that you always use the most current version of the tool. We're currently in version 1.0. And lastly, to direct any questions, if it's a private development project, to your PDS project manager, Planning and Development Services. Or there's also a BMP program email that is just a generic email address, and the question will be routed to the right county staff to answer the question. So again, there's pathways here to direct questions too. All right, so this is at a glance what the Design Capture Volume or DCV tab looks like. Like I said before, it has 10 different columns, and you know, the light green cells are the ones where you're going to do your inputs. In this case, your first column on the left shows less. It doesn't show any gray cells. That's because some of the inputs there predetermined that you're going to have additional information to input, and that's where those cells will go from gray to light green. And then you're going to have your last cells, which are going to be your outputs. So you just can see it a little bit more if you focus on only one column. So the spreadsheet is intended and designed to have different inputs. You know, like the first are standard drainage basin inputs. Then you go into SSD BMPs that are being proposed, like your dispersion areas, rain barrels, or tree wells. Then your inputs on the dispersion areas and rain barrel inputs, which could be optional. Then your initial runoff factor calculations, and those will be automatically populated based on your input. Your dispersion area adjustment and rain barrel adjustments, again, those will be automatically populated because they're white cells. And then lastly, your last 4 rows will be your results. And we're going to be going over an example later in the presentation. All right, then we go into the dispersion areas tab, and this is what it looks like at a glance. Again, we keep using the same figure, so when you open up the spreadsheet, you'll see the figure, so you can always refer to it, and then you'll see the rest of the tab, or the rest of the cells. In this case, you start looking at either dark green, depending on how you look at the colors, or fluorescent green, which I like to call it. And that particular shade of green tells you that some of those cells have already been pre-populated based on your inputs on your previous tab. Next. All right, so in this case, we have those were previously populated. Some are standard dispersion area inputs, and there's going to be some light green cells in there where you need to input additional information in order to complete the example. Now, if any of the additional information that you enter in the light green cells does not compute, or you start getting orange cells at the bottom, that means there are some things that you need to consider in your design, and you need to change some of the inputs so you can have no more orange messages in your results, which is your last three bottoms, which is your DCV requirement fully satisfied by the dispersion area, is hydro modification control requirements satisfied by the dispersion areas, and are the dispersion area length, slope, and thickness of amended soil adequate. All right, we'll go to the next slide, please. And lastly, within the dispersion areas tab, we have a note at the very bottom of the spreadsheet that tells you these are some of the ways you can disperse flow within the dispersion area. So the different ways are sheet flow, a spreader, roof drains, curb cuts, or other. And if you choose other, then you would document that in the PDP SWQMP. Now we go into the tree wells tab. Again, you have 10 columns to do your inputs, and you'll have your illustration on the right, which gives you some of the parameters that you're going to need. Again, you have some dark green cells at the very top. Those are going to be pre-populated based on your DCV inputs in your first tab. Then you're going to have your light green cells, which is what you're going to input. And then your white cells is going to be auto-populated and giving you the results. So if we focus on only one column this time around, you have your pre-populated dark green cells, which are the standard tree well inputs. And then some of those will be light green, which we need to include. Some of them will be soil type. Some of them will be the type of tree. In this case, it'll be a pull-down menu. Most of these will be pull-downs. The pull-down menu for the trees will not only give you the mature canopy diameter, but it will also give you the common name of the tree species, so you can just go hand in hand. And then you'll also you also need to input other parameters, such as your soil depth, your number of tree wells that are proposed within that DMA, your soil installation, and one side by the other side, assuming it's a cube, and then that will give you. So those were the standard tree well inputs. Then you're going to get your tree data below. One of them is that you automatically get populated the botanical name of the tree species, because the landscape plans typically require to have both names in there. And then you're going to have some other outputs like tree well sizing calculator outputs, and then lastly the 3 lines, which are the most important ones. You want to make sure that you don't get any orange color cells in there, that you just get plain white. So the 3 questions are: your tree well soil installation requirements met? Is the remaining DCV requirement fully satisfied by the tree wells? And is hydro modification control requirement fully satisfied by the tree wells? So if the answer is yes to the 3, then you're pretty much done with that drainage management area. All right, so now we're going to go and give you an example project using this new tool. And we're going to have Laura Henry help us with the example project. Laura?
Thank you, Renee. This is Laura. Let's start the example project. Okay, so as Renee discussed, the spreadsheet is set up as steps 1 and 2 and 3, and it's set up that way intended to be a pretty similar format to the pollutant control spreadsheet. However, you will see in this example that you don't always need to use all 3 steps. we're going to use steps 1 and 2 for dispersion, and then we're going to use steps 1 and 3 for the tree well example. It is possible to have a dispersion area upstream of a tree well, and then in that case you'd use all 3 steps. But just for the purpose of this example and to keep it simple, we're not going to combine the BMPs. We'll just do 2 separate drainage management areas and design 1 BMP for each of them. This is the drainage management area map for the example project. And you can download this example project from the county's website, from the county's development resources page. This example project has an example PDP SWQMP, and you'll find the drainage management area map in attachment 2, and also the SSD BMP calculations you'll find in attachment 6. So for this example in this presentation, we're going to look at a dispersion area that's in the light green bubble on your screen and a tree well for the dark green bubble area. Okay, let's start the dispersion area. This is the data for our example. We're going to assume that hydromodification control is required for this project. And let's assume that we've looked up the 85th percentile rainfall for this project, and it's been determined to be 0.52 inches. On our drainage management area plan, we see we have, in this DMA, we have 1,840 square feet of impervious surface that's directed to pervious area. That is the impervious is the total of the 1,560 plus the 280. And then we have a total of 3,360 square feet of engineered pervious surface that serves as dispersion area. Now, all of the impervious area travels across at least 36 feet of the pervious area, so we'll use 36 feet for our length. Let's assume that the slope of this lawn area is 2%, and that we will amend the soil 12 inches thick for this example. And the flow is going to be dispersed across the width of the dispersion area through sheet flow. It comes off the entire width of the walkway. If the building roof has roof drains, it may have a couple of points of discharge of the roof drain, but as the flow crosses over the sidewalk, the walkway area, it will become dispersed across the width of the pervious area. So all of the impervious area manages to get across at least 36 feet of the pervious area before it gets collected into the storm drain system. We're going to start on the DCV tab titled Step 1 DCV, and the first thing we do is we're going to enter the drainage basin ID number, then the 85th percentile rainfall, and the hydromodification control applicability in rows 1 to 3. The next thing we want to enter is the data for the surfaces in the DMA. And since we're going to be designing dispersion, we're going to need to use rows 13 and below for the surfaces. That's the surfaces where the labels talk about it being directed to a dispersion area or it's serving as a dispersion area. Now, initially when you open the spreadsheet, by default, these are grayed out and they don't take data. But as soon as we select a yes in row 11 for does the tributary area incorporate dispersion and or rain barrels, that yes will activate rows 13 to 21. It'll cause them to turn light green and you'll be able to enter data in those rows. It's very similar to the pollutant control spreadsheet for Appendix B. We have the same function in that spreadsheet. So just think of it as similar to that. As long as you've toggled on row 11, you'll have access to the surfaces for the dispersion area. So we enter the total impervious area draining to pervious area in row 13. That's the 1,840 square feet. And for the pervious surface, this project is going to be using amended soil in accordance with fact sheet SDF. In fact, it has to because hydromodification applies. So we are going to have to use the engineered pervious surface. So the project will be using 12-inch thick amended soil. So we'll enter that in row 15 for engineered pervious surfaces serving as dispersion area. So that's our 3,360 square feet. So after we've entered the surface data, the white cells that are in rows 22 to 37 will be automatically calculated. For a dispersion area to be used as an SSD BMP, we're looking for the DCV in the last row in row 37 to go down to 0. And this will happen if we've provided enough pervious area so that the maximum impervious to pervious ratio is not exceeded. So what's going to happen in the calculations is the spreadsheet will determine the ratio of impervious area to pervious area, and then it will do the DCV reduction factors, and it'll calculate the reduced DCV. And for dispersion to be used as an SSD BMP, we need to reduce it all the way down to 0 in line 37. That completes step 1, DCV. Now we'll continue on to step 2, dispersion area validation. So this is the dispersion areas tab for step 2. And the data that we entered in step 1 is showing, but the results at the bottom are in orange and they say incomplete. And that's because we've got work to do in this step. Now this slide is showing the full view of the tab, but we'll go ahead and zoom in on just the one column that we're working for the next few slides so you can read it a little bit better. So the data that was provided or calculated in step 1 has carried over to step 2 in the dark green cells in rows 1 to 6. And in row 6, the ratio of the dispersed impervious area to pervious area is showing as 0.55. That is well within the maximum allowable ratio of 1 to 1 in order to use this BMP for the hydromodification control. So now we need to enter the details about the dispersion area to confirm that it meets the criteria for the flow travel length, slope, and thickness of amended soil. So we're going to enter the data that matches the plan. We had 36 feet of travel length, and we have a 2% slope, and the project will be having 12 inches thickness of amended soil. So we'll go ahead and enter those in rows 7, 8, and 9. In row 10, we can also indicate how the flow is dispersed across the total width of the pervious area. And this is something to help your plan reviewer know what to be looking for on your grading plan. So we'll go ahead and select sheet flow in row 10. Actually, when you see the full size of this sheet, down at the bottom, there are footnotes that explain what the different types of manners of dispersing the sheet flow are, because there's a drop-down list in sheet 10 that we used to select sheet flow there. So after the data has been entered in lines 7, 8, and 9, the results in lines 11, 12, and 13 are going to be updated. If for some reason something didn't meet the required criteria, for example, if the travel length was too short or if the slope was too steep, there would be a warning message in the box at the bottom. So you'd see orange in the cell that has a problem, and then under warning messages, it'll give you a reference for what line number has a problem and some suggestions for what you need to do to correct it. Now in this case, for the example problem, the design that's entered in this example meets the criteria. So lines 11, 12, and 13 say yes, and there are no warning messages, and so this DMA is complete. Just to close out this example, a reminder of what we need to have on the DMA exhibit in order to be able to review and verify the design. We'll need to see the direction of the flow, showing that the impervious area is intended to drain across the pervious area. And we'll need enough information about the total square footage of each type of area to be able to verify the ratio. And we'll need to be able to verify the travel length. The plans should also have notes indicating the type of pervious surface to be used. Now let's start the tree well example. This is the data for our example. Again, it's still in the same project site, so we have the 85th percentile rainfall we determined was 0.52 inches, and hydromodification control is applicable for this site. For the tree well, we do need to know the hydrologic soil group of the native soil. And so for this example, we're going to assume it was type C. Now looking at this DMA, you can see we might actually have enough pervious area that we could get some credit for reducing DCV through dispersion, but just for the purpose of this example, to keep it simple and only do one BMP, I'm not going to quantify that. You probably could, but again, just to keep it simple, I'm not going to for this example. So we're going to say that we have 1,524 square feet of impervious surfaces not serving as dispersion area. And the pervious surface is 1,784 square feet. this tributary does not incorporate dispersion or rain barrels. It is using a tree well. So we'll start on the DCV tab, where we enter the DMA ID, the 85th percentile rainfall, and the hydromodification control applicability in the rows 1 through 3. Next thing we're going to do is enter the DMA surface data and the SSD BMPs proposed. So since we're not quantifying dispersion in this example, we're going to enter the surface data in rows 4 through 10, where the surfaces are not directed to or serving as a dispersion area. So we have our 1,524 square feet of impervious surfaces in row 4 and 1,784 square feet of pervious surface in row 6. And then we toggle on row 12 for incorporating tree wells. So after we've entered the surface data, all the white cells in rows 22 to 37 are going to be automatically calculated. And in row 37 is where we find the total design capture volume that needs to be managed for pollutant control, which comes to 67 cubic feet in this example. And that's the pollutant control only design capture volume. That completes step 1, DCV. Since we're not quantifying dispersion, we're going to skip step 2 and we'll go straight on to step 3, tree well sizing. So this is the tree well sizing tab for step 3. The data that we entered in step 1 is showing, but just like with the dispersion areas sheet at the bottom, right now it says incomplete because we need to size the tree well now. So now we'll zoom in on the one column that we're working on. The data that was provided or calculated in step 1 carried over to step 3 in the dark green cells in rows 1 to 3, and now it's our job to fill in the light green cells. As we get started with the design, we can go ahead and start with just rows 4, 5, and 6. The hydrologic soil group was given at the beginning as group C, so we'll go ahead and select group C. Now let's assume that we coordinated with the project landscape architect and we decided that we're going to try a strawberry tree that has a 20-foot mature canopy diameter. If we're going to go ahead and select that, we're selecting it from a drop-down list that's built into row 5. So when you're interacting with this spreadsheet, you'll see a couple of places where there are drop-down lists. That's to make sure that we don't get any spelling mistakes or other things that will trip up the spreadsheet. So for consistency, you'll go ahead and select it from that list. And if you're using a tree that is not from the tree palette table, there are options available in the list to select other and select it based on the mature canopy diameter. So there'll be, for example, a 20-foot other or a 10-foot other if you need to use that. Let's also assume that the landscape architect, we've talked with the landscape architect and they'd like this tree well soil to be installed 30 inches thick. So we'll go ahead and select 30 inches in row 6. At this point, when rows 4 to 6 have been completed, lines 10 to 23 are going to be automatically calculated. The results are still incomplete because we need to put data in lines 7, 8, and 9 that confirm what we're actually proposing to use for the number of trees and for the dimensions for the tree well soil. But we can get some help for that from the spreadsheet. So just by filling lines 4, 5, and 6, we can now look at lines 17 through 20 to see the spreadsheet calculated minimum requirements for the number of trees, or the number of strawberry trees that we'll need. And also to find out the minimum area of soil is that we need, which is based on the tree that we selected and the depth. Also, I want to point out, because hydromodification control applied in the example, while the DCV for pollutant control was 67 cubic feet, built within the spreadsheet in row 15, the spreadsheet has looked up what the DCV multiplier is to meet the flow control requirements for hydromod. So based on the soil type C and the depth 30 inches that we selected, the spreadsheet has looked up from the table the DCV multiplier is 2.5, and it's applied that to the DCV. So in row 16, we see our required retention volume that we need to meet hydromodification control. And then the number of trees required will be based on making sure that we satisfy that RRV. So based on this, the calculations have determined that it would just take one strawberry tree to satisfy the RRV requirement, and the total area that we're going to need to install the tree well soil is about 251 square feet. And we get an approximate required width and required length that'll give us 251 square feet, but we don't actually have to install it as a square. This is just a guide to give you an idea of what it would look like. You can now, in lines 8 and 9, put in a length and a width. And as long as your length and width come to multiply out to 251 square feet or greater, it'll be satisfied. Although the spreadsheet will also be looking for other issues, such as if the soil, if the length, say, is so long that the soil extends too far out. So probably the best way to do this would be download the spreadsheet and go ahead and just try things. Just try it out and see what happens with the numbers. So for this example, our results are telling us we need just one tree and approximately 16 by 16 square feet. So after we enter the data in lines 7, 8, and 9, describing how we're going to configure this tree well soil, that's when lines 24, 25, and 26 will be updated. At this point, if something didn't meet the required criteria, for example, if we reduced the width and increased the length to make a rectangle, but the dimensions put the edges of the soil too far from the tree canopy, at that point, that's where you'd see a warning in the box at the bottom. And so the line 24 might still be orange and say incomplete or say no, and then you'd have a corresponding warning message telling you what to do to correct the problem. The design that's entered in this example meets the criteria, so lines 24 to 26 say yes, and there are no warning messages. In conclusion of the tree well example, be sure to show on the plans the mature tree diameter, as well as the type of tree that you're using, and then the area and the depth of the tree well soil. The plans should also show how runoff will be directed to the tree. So go ahead and download this from the Development Resources webpage and try some numbers in it. The best way to learn it, to some numbers and just try out some things, see what happens when you enter the different numbers. You can look at the warning messages and you can look at what it takes to complete them. And thank you, and we can take your questions now on the spreadsheet tool and the example problem.
Great. Thank you, Renee and Laura, for walking us through the spreadsheet, the BMP tool, and the example problem. So we do have a few questions, and Robert Reiner has provided 3 questions, so I'd like to kind of combine those for, I think probably for Renee. But will a combined tool be created in the future that includes all the new elements when using them both? And then also, is it wise to not require a PE or a landscape architect to sign and stamp a calculation? And is that allowable per the MS4 permit? And lastly, who will be taking responsibility for design errors with the unstamped and signed calculation problems when not installed properly, especially if the engineer of work isn't the one designing the SSD but needs to certify in the verification for the O&M?
All right, so 3-part question. I'll start with the first one, and I'm actually reading them. So
okay, great.
So will a combined tool be created in the future that includes all of the new elements when using them both? I'm not sure if it would be practicable. I mean, what we're trying to do here is to use different tools depending on the scenario where you're in. If you happen to have a drainage management area, and when you want to comply using SSD-BMPs, then you use the SSD-BMP tool. You may have other DMAs where you are not going to be able to use an SSD-BMP tool and just use a structural BMP, and therefore you have to use the other pathway with the other two spreadsheets. It would be really cumbersome to try to combine everything into one spreadsheet, and it would be almost very difficult to understand the concepts that we're talking to teach you here. So for now, I'm going to say no, and depending on how this new tool goes, and we'll see if we need to revisit this and combine anything else. But for now, the answer to that is no. The second question about the PE or landscape architect to sign and stamp and sign a calculation, and is this allowable per the MS4? So regarding the MS4 permit, the MS4 permit doesn't really tell you who needs to certify something, who needs to sign something. It's really up to each jurisdiction to make that requirement as to who needs to sign what document. In this case, the county has decided to continue requiring a registered engineer for structural BMP. Any prior development project that requires a structural BMP, that structural BMP attachment will be signed by a registered engineer. If we're going for the pathway of the SSD BMP, then we are saying that we don't require it, and that is noted in the form itself in attachment 6. And let's see, the third question was about the responsibility of errors. That goes with any project. Ultimately it's about compliance with stormwater requirements, and ultimately it's about making sure that things get reviewed, because they do get reviewed by a county staff, that things get inspected, that they get inspected by county staff, and ultimately the certification, which in this case will not require for SSD BMPs, will not require a registered engineer, but will still require all the other documentation that we do require for structural BMP. So it's just one less of a burden. And just to add to this comment, so when we envisioned this pathway back in the day, the goal was to make it easier for those smaller projects that happen to be residential and they happen to be a priority development project, to make sure that we allow them a different pathway that would be somehow easier to comply and not as onerous as a structural BMP pathway. So that's what led to the county coming and producing this particular guidance, and now where we are with this tool and with the new Appendix I.
Great, thank you, Renee. I'm going to move on to Julie's presentation.
Yes, thank you, Jane. Hi everybody, I'm Julie Hughes. I work in watershed protection, and I'm one of the reviewers of the BMP installation verification packages for private projects. So the BMP installation verification form is PDP SWQMP form attachment 10. This is a fillable form. It's located on the Watershed Protections Development Resources webpage. This form is submitted to your county inspector after construction of your permanent BMPs is complete. So what is the verification process for BMPs? Permanent BMPs for all priority development projects must be accepted into the county's inventory prior to release of construction permits or granting of occupancy. The verification process for permanent BMPs has not changed with the 2020 update to the BMP design manual, but there is an updated attachment template posted online. More guidance for the BMP verification process can be found in Chapter 8 of the BMP design manual. So at the final stage of a PDP project, the county requires SWQMP Attachment 10, the BMP installation verification form, to be submitted to their inspector, either PDCI or PDS building. The inspector will verify in the field that the permanent BMP has been constructed in accordance with the plan details. If the inspector concurs, he or she will sign the last page of the form and submit it to Watershed Protection as a package, along with the approved SWQMP for the project. And then Watershed Protection reviews the package. And this BMP installation verification form must be signed and accepted by Watershed Protection prior to any granting of occupancy and prior to record plan. There's an example of a completed attachment 10 BMP verification form, and it's found at the end of the PDP SWQMP example that Laura Henry was going over for the SSD BMP tool on the Development Resources webpage under Calculators and Modeling Software, as shown here on this slide. So I'm going to go over an example of an acceptable BMP installation verification package. And this example, we're going to use Laura Henry's PDP swamp example that we're supposed to on the website, as we just showed you. There's 4 parts to this form. Part 1 is the project information, which is pretty straightforward. You should make sure that the owner information is current and up to date. And this will be the responsible party information that the Watershed Protection Program will use for future maintenance verification mailouts. I did mention partial verifications. On page 2, there's a place to document partial verifications. This page can be left blank for most projects or deleted. However, if you have a larger project that's being completed in phases, this table should be completely filled out with the very first verification submittal. All the structural and significant site design BMPs should be listed for the entire project on this table. Part 2 of the form is the BMP inventory information. That's a very important part of the form. This table should list all of the BMPs that you're submitting for verification and be completely filled out with the BMP ID, the BMP name, the number of BMPs, the DMA. In this example, they're just SSD BMPs, which do not have maintenance category or recorded document number. For the SSD section, there are pull downs for tree wells or dispersion areas, and you should be able to add rows pretty easily on our new updated template. Part 3 is the required attachments. It's a checklist. Photographs are always required. At a minimum, we require final construction photos of the BMPs. We also like to see additional photos of the BMPs that were taken during the construction process. And we can go over that in the next slide. Recorded maintenance agreements are required for private Category 1 and Category 2 BMPs. Significant site design BMPs, such as tree wells, do not have a category and do not require a maintenance agreement to be recorded. Construction plans are always required to be included with the submittal. Landscape plans are only required if the BMPs are vegetated and included on a permitted landscape plan. If that's the case, we ask for the final landscape plans and the water use authorization letter from the county landscape architect. Here is an example of photos submitted for tree wells. So I'm looking for consistency with the plans and the swamp details for the BMP. In this example, there are 2 trees, and the photos include the different construction elements such as slotted underdrain and amended soil. Photos should always be labeled with the BMP identifiers and the date the photo was taken. And for tree wells, there should at least be 1 photo that shows how the stormwater runoff enters the tree well. And in general, I would say the more photos, the better, so plan ahead and you can't go wrong in documenting that you constructed your BMP properly. Part 4 is the prepare certification. Structural BMPs such as biofiltration basins must be certified by a licensed engineer. Significant site design BMPs such as tree wells, on the other hand, do not require an engineer's signature. However, if your project contains a mixture of both types of BMPs, structural and SSD, then you would need an engineer's signature on Part 4. WPP acceptance, what happens next? Once watershed protection has accepted the BMPs, the county inspector can continue the process of closing out the project. Watershed protection will inventory the BMPs in an asset management system in order to track their maintenance in perpetuity as required by the MS4 permit. Each year, the County of San Diego is required to verify that structural BMPs located on properties in its jurisdiction are maintained and operating effectively. Okay, I just wanted to mention that we have a new app for smartphones to help owners of structural BMPs submit their annual maintenance verifications. The annual maintenance verifications are due prior to the rainy season on October 1st. The self-verification program doesn't currently apply to owners of significant site design BMPs. And more information can be found on our website. That's about all I have. If anyone has questions, please type them in the Q&A and we can address them in a few minutes. And now I'll hand it over to Renee Vidalis.
So thank you, Julie, for that excellent presentation on that part of the process, which tends to be sometimes not remembered, it tends to be sometimes forgotten, but it's something that is required at the tail end of construction and before closing the project. So it's very important for the county to receive that information to make sure that everything is accurate, and at the end, we put those BMPs in the inventory. So now I'm going to go over some recommended best practices. The title of, or the definition of BMP is best management practices, but in this case, there's other practices other than just structural, site design, or SSD-BMP. So I'm going to go and just give you a few examples of some good things that the county has seen and how we want to continue improving documentation as we move forward. So we have an example of recently constructed BMP. This is a photo that we received. So like Julie was telling us earlier, we want to see photos with, if it's a vegetated BMP, make sure that the vegetation is clearly shown and it's at least showing to some degree of, establishment. And in this case, the good example is, in addition to the good photo of, the BMP with the vegetation, but it's also the usage of this particular type of sign, which is the temporary BMP signage that we covered before. So the sign says, boundary of structural best management practice by retention basin, do not disturb, in bold letters, end quote. So that's a really good use of, how we can protect those BMPs that were recently completed, they're operating, and just to make sure that whoever's there, that they don't start running equipment over them. And, there's going to be some really good use of these type of signages in the future, but at least we're recommending these type of signages, and those will be temporary signage. We don't intend for these signage to be permanent at all. This example shows you the low flow orifice, and we can talk for hours about low flow orifices, but in this case happens to be a box, a 24-inch riser orifice box with graded inlet, and at the bottom it will show a 6-inch pipe with a 1/2-inch orifice, diameter orifice. So on the left, that's where you see the 6-inch and the 1/2-inch. It's a little exaggerated, but just that's what it's supposed to be, and it's shown on the plans accurately. And now we see how it is on plan. If you're looking and removing the lid, that you can see how the orifice is shown on the top, and the rest of the pipe where it's going to go, it's going to be on the bottom of the photograph. So these things actually happen in practice. The good example here is that it was a box, so you can actually take a look at it, inspect it, and then do some maintenance. However, if this happened to be a pipe, and it gets really challenging when it's not a box where you can actually go down and do the maintenance, but when it's a pipe, that becomes really challenging for not just inspecting that the orifice is there, but also for maintenance in the future. Another good example is that since we release this particular fact sheets for property owners, they're also under the development resources page of the county under maintenance. And these are for property owners. So these are the people who are going to own the BMPs in the future to maintain them. So we're going to make sure that we have plain language for them to understand and not technical language, because they don't need that. So if you can include those in the maintenance section of your attachments of the prior development SWQMP, that would be great. The previous slide was on tree walls. This one is on dispersion area. So same thing, if you can include these type of fact sheets for the property owners in the PDP SWQMP, that would be great, because sometimes property owners, and more is happening now, are getting a copy of the PDP SWQMP, and it's just a document that's very technical for them. So if you include this particular documentation in there, it'll be easier for them to read what they're owning and what they're supposed to maintain. And then lastly, similar photos like Julie was showing you before, when you have a completed structural BMP or SSD BMP and you take the photos, make sure that the photos clearly show the entire area, that you show some degree of establishment in the BMP, and that, everything looks clean and ready to go. And these were the photos would be more than likely to be acceptable on the first pass, other than going back and forth and trying to get additional documentation when you're trying to close a project and you're waiting on occupancy. So the better information you submit, the easier and faster it will be to get that verification package approved, and the occupancy can be granted on a project. And that's pretty much it. Entertain a few questions, Jane.
Yes, thank you, Renee and Julie, for that session. And we don't have any questions, at least in the Q&A, for this particular session. But if we go back, we do have a couple questions, if we can sneak them in the next, say, 4 minutes. We've got an anonymous attendee asking, regarding the use of street trees within the right-of-way, why are Green Street portions of projects required to treat the full DCB? Is this an above and beyond county requirement, or is this the standard set by the MS4 permit?
All right, so I'll try to answer as quickly and as thoroughly as I can. So for any, if you recall, on the municipal stormwater permit, there's a pathway for green streets PDP exemption for a certain type of projects, typically linear projects, typically projects where it's only a road and you're only widening or redeveloping the road. For these type of scenarios, there's no performance standards specified in the MS4 permit. The only thing that's listed in there is that it needs to meet the criteria of the US EPA, which is federal green streets guidance on green streets or green infrastructure. So it just sets a pretty interesting requirement because it doesn't really tell you other than use that particular high-level document to create your own guidance. So what the county did is we created our own guidance, which was for any green streets PDP exemption type project, then the performance standard would be to meet the pollutant control 85th percentile requirement.
Great, thank you, Renee. And our next question, the assumption that rooftop flow translates to sheet flow spanning the width of the dispersion area appears to be a theoretical concept that is virtually impossible to implement in the built environment, even with a flow spreader. How exactly will this look in the field?
Great question. I think a lot of it is, try to think about having a uniform slope, having to make sure that your flow spreader is going to spread over that area that you're designing it to be. It's theoretically, it's supposed to work, and, flow is going to go where you directed it to go to. In this case, if you make sure that everything's spread out and you have, whatever uniform slope that you're calling out, then, there's a maximum slope, of course, but then the spreader is supposed to work. A lot of it will have to do with the vegetation that you're planting, whether you have consistent vegetation. If you start planting different types of vegetation, they may affect the way the water is going to be distributed across.
And this is Laura. I'd just like to contribute that, and first of all, an apology if I made it sound as though we really expect every inch of perfection here. But the general concept that we're looking for is we want to make sure that the full dispersion area gets used. And so that could be curb cuts that are every couple of feet from the parking lot, or it could be multiple roof drains from the building instead of just one roof drain on the corner. So I think we understand that we might not have perfection and get every inch along the width of the area, but what we're looking for is to see that it's not concentrated in one point and that it's not directed to a channelized type of conveyance, and also that it's laid out so that we aren't in danger of it creating its own channelized conveyance because it's concentrated to a point that it might be erosive. So we do our best with the grading plan to see if we can spread it across the full width of the area. Thank you.
Okay, and then we've got two last questions that are somewhat related to tree wells. So is 30-inch the minimum depth for the tree wells? Can we go shallower? And the next question is related to the tree well example. Does the DMA, in particular the pervious area, include the area of the tree well?
Okay, so I'll answer the first question, and I'll see if I can answer the first part of the second question. So the question was about the minimum depth of the soil depth for tree wells, and when we did the sizing factors, when we modeled them, we used current practices based on what landscape architects use for when they are recommending trees, and we used predetermined 30, 36, 42, and 48 inch, which are the typical tree size boxes that you can find out there. And that's also, to make it easier, because the more parameters you include when you're doing calculations, the harder it is to verify. So we wanted to give some specific parameters. So no, we didn't include anything that was less than 30 inches in this case. And the second question was in relation to
Does the DMA, in particular the pervious area, is that included in the area of the tree well? Does that include the area of the tree well?
I'll let Laura answer that, because you do have, the soil and your tree well itself, and then you have the mature canopy diameter on the very top. So I would tend to lean more on what's on the plan, which would be, what you have on the ground. And Laura?
Yes, thank you. I'll answer this. The DMA area does include the area of the tree well. It was encompassed within the landscape area, and it received, so it has a runoff factor of 0.1. Even understanding that, rain that lands directly on the tree, that's a runoff factor of 1.0 because it landed directly on the tree. But we have some allowances to be able to just go ahead and, for simplicity, encompass that within the landscape area, because the tree well itself is part of the landscape area. So the tree well, the soil, the tree, all of it was encompassed within the total amount of pervious area that we entered in the spreadsheet as pervious area. Thank you.
All right, well, thank you all. And so this is going to conclude our presentation today. And could we give all of our speakers today, Renee, Jeremy, Laura, and Julie, a round of applause? So thank you very much. And Renee, did you have any closing additional remarks that you'd like to mention to our folks?
Thank you, Jane. I don't have a whole lot other than we will be posting the slides on the county website. Again, San DiegoCounty.gov/stormwater. Then you go to the droplet that's called Development Resources, and then you'll go into all these different categories. You choose the training category, and then that's where we will be posting the slides for this presentation. And in the future, once we finish up the video, then we'll be posting a link to that video in the same location. Thank you, everybody, for attending. This has been interesting experience for us, doing everything remotely instead of, face-to-face in a hearing room. We appreciate your attendance, and hopefully this was informative and useful to you. And, we'll try to respond to as many questions as we can that were left unanswered on the chat. So thank you very much for your attendance.
Thank you. Have a great afternoon, and thanks for joining us. Bye-bye.
Thank you.